Picture this. You're on a train moving at constant speed. You toss a ball straight up and catch it. To you, the ball went straight up and down. But to someone standing on the platform, that ball traced a curved path through the air. Who's right? The answer revolutionized our understanding of space, time, and reality itself. Albert Einstein's theory of relativity isn't just one theory. It's actually two groundbreaking ideas that fundamentally changed physics forever. Special relativity, published in 1905, and general relativity, completed in 1915, revealed that our intuitive understanding of the universe was completely wrong. Special relativity starts with a simple but profound observation. The speed of light is constant for all observers, regardless of their motion. This seems innocent enough until you realize its shocking implications. If light always travels at the same speed, then space and time must be flexible to accommodate this rule. This leads to time dilation, one of relativity's most mind-bending consequences. Time literally runs slower for objects moving at high speeds. If your twin brother traveled to a distant star at near light speed while you stayed on Earth, he would age more slowly than you. Upon his return, you might be decades older while he's aged only months. This isn't science fiction. It's been measured with atomic clocks on fast-moving airplanes. Length contraction is equally strange. Objects actually shrink in the direction of their motion as they approach light speed. A spaceship traveling at 90% the speed of light would appear half its normal length to a stationary observer. The faster you go, the more you shrink, until at light speed your length would theoretically become zero. But Einstein didn't stop there. His famous equation, E equals mc squared, revealed that mass and energy are interchangeable. A tiny amount of mass contains enormous energy, the principle behind both nuclear power and atomic weapons. This equation explains how the sun generates energy by converting a small amount of its mass into the light and heat that sustain life on Earth. General relativity takes these ideas even further, revealing that gravity isn't a force pulling objects together, but rather the curvature of space-time itself. Imagine a bowling ball placed on a stretched rubber sheet. It creates a depression that causes marbles rolled nearby to curve toward it. Similarly, massive objects like stars and planets warp the fabric of space-time, creating what we perceive as gravitational attraction. This theory predicted phenomena that seemed impossible at the time. Black holes, regions where space-time curves so severely that not even light can escape. Gravitational waves, ripples in space-time itself that travel at light speed. Both have now been detected, confirming Einstein's century-old predictions with stunning precision. GPS satellites orbiting Earth must account for relativistic effects to maintain accuracy. Time runs slightly faster in orbit due to weaker gravity, and slightly slower due to orbital motion. Without Einstein's corrections, GPS would accumulate errors of several miles per day, making navigation impossible. Perhaps most remarkably, relativity shows us that there's no universal now. Events that appear simultaneous to one observer might occur at different times for another moving observer. Past, present, and future aren't absolute. They depend on your frame of reference. In a very real sense, all moments in time exist equally in what physicists call the block universe. Einstein's theories didn't just advance physics. They transformed our philosophical understanding of reality. Space and time aren't the fixed stage where events unfold, but dynamic participants in cosmic drama. The universe is far stranger and more interconnected than our everyday experience suggests. From the smallest particles to the largest galaxies, from the birth of the universe to its ultimate fate, Einstein's relativity continues guiding our exploration of cosmic mysteries. More than a century later, we're still discovering new implications of these revolutionary insights. Ready to explore more mind-expanding physics? Subscribe to journey deeper into the surprising truths about our universe. Einstein showed us that reality is far more extraordinary than we ever imagined, and we've only just begun to understand what that means.